Well, hello, year 11. Welcome to your feedback session for the homework, page 118 to 122. Same rule as always, get your green pen, give yourself a mark if you got the answer correct, write down the correct answer in green if you got it wrong. And same as always, we're going to try and do it in less than 15 minutes, and we shall start now. Let me hide this. So, this question is about atoms forming ion by losing or gaining electrons. Which of the following statement about the atoms of metallic element is correct? Metal atoms usually lose electron to become negative ions. This one's incorrect, partly. They do lose electron, okay, but because the electron is negative, losing them make the atom positive, not negative. So it can't be the first one. Metal atoms usually gain electrons to become negative ions. No, they don't gain electrons, they lose them, so it can't be that one. Metal atoms usually gain electrons to become positive ions. This one is correct. They're losing negative charges, therefore they become more positive. So, whoa, what did I say? Oh, sorry, forget what I just said. Metal atoms usually lose electrons to become positive ions. My God. Okay, first mistake of the video, sorry. Next one. The diagram below shows the ions of four elements and four description about where the elements can be found in a periodic table. Draw a line to match each of the four ions to their description. So A plus, if it's plus, it means that it has lost an electron. If it's lost an electron, it's a metal. If the charge is plus one, only one electron was lost. So the element had one electron in its outer shell. It must belong to group one. So a metal from group one is A plus. D minus, if it's minus, it gains that electron. Therefore, it has to be an element that has 7 electrons in its outer shell, gains an extra one to form a minus 1 charge. So it should be a non-metal from group 7. X2 plus, if it's 2 plus, it has lost 2 electrons. If it's lost electron, it's a metal. And if it's lost 2 of them, it must have had 2 on its outer shell to start with, like all the elements of group 2. So X2 plus X is a metal from group 2. And Z2 minus, if it's 2 minus, it has gained 2 electrons. If it has gained 2 electrons, it's a non-metal. And it must have had 6 electrons in its outer shell, so it's a non-metal from group 6. This question is about sulfur atoms and sulfur ions. Sulfur is in group 6 of the periodic table. That means it has 6 electrons in its outer shell. That means it wants to gain 2 in order to get a full outer shell, forming 2 minus. S2 minus is a sulfide ion. Sulfur atoms have the electronic structure 286. Write the electronic structure of a sulfur ion. So it's gained 2 electrons, which are added to the outer shell, making it 288. Sulfur gained 2 electrons to get a full outer shell, which are added to the outer shell, 288. Name the element that has atoms with the same electronic structure as a sulfur ion. So it is the element that has in total 18 electrons and 18 protons. It's argon. All right, choose from the formulas on the left to complete the table showing the dot and cross diagram and formulas of various ionic compounds. You won't need to use all the formula. So we have one Na plus and one Cl minus, that's NaCl. We have two Na plus and one O2 minus, that's Na2O. And for the last one, we have one magnesium and two chlorine or two chloride, that's MgCl2. Ionic bonding is one of the 3 types of chemical bonds found in compounds. In which of the following compounds are the particles held together by ionic bonds? So remember, ionic bonds is between a metal and a non-metal. The metal is going to lose electrons. The non-metal is going to gain electrons. They're forming ions. They're attracted to each other. Calcium chloride. Calcium is a metal. Chloride is a non-metal. Therefore, they're going to form ionic bonds. Carbon dioxide, made of carbon and oxygen. Both carbon and oxygen are non-metals, so they're not going to form ionic bonds. Phosphorus trichloride. Phosphorus is a non-metal. Chlorine is a non-metal, so no ionic bonds. Potassium oxide. Potassium is a metal. Oxygen is not is a non-metal, so those are going to form ionic bonds. And nitrogen monoxide. Nitrogen is a non-metal. Oxygen is a non-metal, so no ionic bonds. So only calcium chloride and potassium oxide are going to form ionic bonds. The dot and cross diagram below shows the formation of lithium fluoride from its elements, so lithium and fluorine. The diagram is incomplete. Complete the diagram by adding an arrow to show the transfer of electrons, the charges of the ions, and completing the outer electronic structure of the fluoride ion. So the electron is going to be transferred from lithium to fluorine. Lithium is going to lose an electron, forming Li+. Fluorine has gained that electron, forming F-. Okay. Make sure when you represent the electronic structure, you had crosses for an element, dots for the other. Name the force that holds the ions together in an ionic bond. We have an electrostatic force of attraction between oppositely charged ions. Okay, plus and minus attract each other. State how you can tell from a dot and cross diagram that the particles in a compound are held together by ionic bonds. The particles in a compound are oppositely charged. Okay, so you really need to indicate those charges. In that case, Li is positive, fluoride is negative. Next one, figure 1 shows the outer electron structure of magnesium and oxygen, so 2 electrons on the outer shell of magnesium, 6 on the outer shell of oxygen. Draw a similar diagram to show the electronic structures and charges of the ions that form when magnesium reacts with oxygen. So both electrons from magnesium are going to be transferred to oxygen, so magnesium is left with no electron in its outer shell, forming a 2+ ion. Oxygen is going to gain those 2 electrons, forming a O2- ion. Make sure you have 6 crosses, 2 dots. Explain how an ionic bond forms when magnesium atoms react with oxygen atoms. So 2 electrons are transferred from the magnesium atom to the oxygen atom, forming Mg2+ and O2-. Oppositely charged ions are attracted to each other. 4 marks. So the 2 electrons are transferred, 2 marks, from magnesium, 2 electrons transfer 1 mark, from magnesium 1 mark, to oxygen atom 1 mark, forming Mg2+ and O2- mark. Oppositely charged ions attracted to each other. Yeah, say a lot, give a lot of details. Next one, figure 2 is a representation of the structure of a compound formed from 2 unknown elements, X and Z. Suggest which group in the periodic table each element is from and give a reason for your choice. So if you look at X, it has 7 crosses and 1 dot. That means it started with 7 electrons on its outer shell, which means it belongs to group 7. Okay, and also if I'm a -1 ion. Element Z has 2+ charge. That means it has lost 2 electrons. That means it had to have 2 electrons in its outer shell. Therefore, it must have belonged to group 2. Okay, group 2 forms the 2+ ions, so has lost 2 electrons. Discuss the uses and limitation of dot and cross diagrams. So the dot and cross diagrams show the charge of the ions. That's good. The arrangement of electrons in an atom of ion. That's good. Which atoms the electrons in an ion originally come from. That's good. And the empirical formula. That's good. The limitation, it doesn't show the structure of the compound and how the ions are arranged compared to each other. And it also doesn't correctly represent the size of the ions. Circle the correct. In an ionic compound, the particles are held together by strong forces of attraction. These forces act in all directions, which results in the particles bonding together to form a giant lattice or giant lattices. These questions about the structure and properties of ionic compound. Which of the following properties is not typical for an ionic compound? Tick 1 box. So because they have strong ionic bonds, a lot of energy is required to break those bonds. So they do have very high melting point and high boiling point. They do conduct electricity in a liquid state because the ions are free to move, but they do not conduct electricity in a solid state because the ions are stuck in position. They cannot move around. Okay, so ions are not free to move, it cannot carry a charge. Name the type of structure that ionic compounds have. It's called a giant ionic lattice. Please use those 3 words to get the mark. Next, sodium chloride is an ionic compound. Fact. Describe the structure of a crystal of sodium chloride. So, NaCl contains Na+ ions and Cl- ions that are arranged in a giant ionic lattice. The oppositely charged ions are held together by a strong electrostatic force of attraction acting in all directions. This is what you need to say to get 4 marks. Okay, so don't forget the name of the structure, giant ionic lattice. Don't forget to say that the oppositely charged ions attract each other and act in all directions. Explain why sodium chloride has a high melting point. It requires a lot of energy to overcome or to break the strong electrostatic forces of attraction between oppositely charged ions, but it requires a lot of energy to break ionic bonds. Therefore, it has a high melting point. You have to heat them up a lot to break those bonds. Next one, potassium bromide has a lattice structure similar to sodium chloride. Potassium belongs to group 1. It's going to form K plus ions. Bromine belongs to group 7. It's going to form Br minus ions. So in each circle, you're going to have to write down either K plus or Br minus. I started with K plus, then Br minus, then K plus, then Br minus, K plus, Br minus, K plus, Br minus, and K plus. Give one advantage of and one disadvantage of using this type of diagram to represent the structure of an ionic compound. Advantage, we can see the charges and the 3D arrangement of ions, as well as the pattern. Disadvantage, it doesn't represent the size of the ions. And what is the empirical formula of potassium bromide? It is KBr, because for each K plus, we have one Br minus. Remember, the empirical formula is the simplest whole number ratio of atom of element in a compound. Table 1 shows some data about potassium bromide. Each of the 3 properties shown in Table 1 explain how the structure of potassium bromide causes the particular property. So it has a very, very high boiling point because it has strong electrostatic forces of attraction between oppositely charged ions, which require a lot of energy to overcome. It has a low conductivity, electrical conductivity as a solid, because the ions are in fixed position in the lattice. They are not free to move and cannot carry a charge. Electrical conductivity of solution is high because in solution the ions are free to move and can carry a charge from place to place. Okay, and that is valid for all the ionic compounds. Very high boiling point and melting point, low conductivity as a solid, very high conductivity in solution or molten. And whoa, this is it. This is it for today. Less than 15 minutes. Well done, me. Make sure you bring your homework back to class to show me you've done the work. Make sure it's fully marked in green. Don't forget to stay amazing, and I'll talk to you soon. Bye bye.